Our Glory Globe TV, here's the breaking news. Yes, scientists discovered new variants of malaria parasite in Ethiopia that are resistant to existing treatments and undetectable by standard diagnostic tests. This situation could lead to a rise in malaria cases and fatalities, complicating efforts to eradicate the disease. The authors detailed their findings from a genomic surveillance study in Nature Microbiology. Already scientists had found in Uganda, Tanzania and Rwanda strains of the parasite that causes malaria that were resistant to most available anti-malarial drugs, and separately malaria parasites resistant to diagnostic tests had emerged in the Horn of Africa. Those parasites have been spreading independently on one to each other, but the new study is the first published report to confirm the prevalence of this type of double resistance malaria strain, said study author Jeffrey Bailey, an associate professor of translational research and pathology and laboratory medicines in Brown University. Now we are essentially seeing the worst case scenario. Parasites with the mutation that make them resistant to treatment have also picked up the chromosomal deletion that make them invisible to the diagnostic test. Bailey said this means that it will be harder to detect people who are infected, and then when infected people are treated with anti-malarial drugs that may not work to stop them from spreading the disease. The standard method to diagnose malaria in Africa is thorough rapid diagnostic test that detects specific parasite proteins in the blood that are highly expressed. The test can confirm malaria even if the patient is asymptomatic. The parasites lacking the genes for those proteins have evolved to be invisible to the test. The first line malaria treatment recommended by the World Health Organization is a combination therapy involving artemisinin based drug compounds which tend to be very effective in preventing death and reducing transmission. The mutation now detected in Africa provide resistance to artemisinin. Bailey's research team at Brown, in close collaboration with the researchers from the Ethiopian Public Health Institute and the University of North Carolina at Chapel Hill, conducted a comparative genomic analysis of malaria parasite samples with the deleted proteins expressing genes that had been collected across 3 regions of Ethiopia, led by Bailey, co-director of the PhD program at Brown Center for Computational Molecular Biology. The scientists used molecular sequencing to assess the prevalence of mutations that confer resistance to artemisinin. Adevifola, a postdoctoral researcher in Bailey's lab, was instrumental in this work and is the